What's up guys, I'm Mass here, and today we're looking at real life graphs, and first question is up from Edexcel. So here we've got a distance time graph, and we're asked between which two times does the car travel its greatest speed. Now on a distance time graph, the steeper the line, the faster the thing's going. So it's stopped when it's horizontal, that means that it literally is not going at all. And then it gets faster and faster the steeper the line, like the higher the gradient. This also works going downwards. If it's displacement instead of distance, you can go downwards, and the steeper the line going downwards, it's also the faster it's going. So we just basically got to answer the question of what point here is the line the steepest. Well, it's obviously going to be this bit here that the line is the steepest. So I would answer the question saying between 0 and, what's that, 20 seconds? Now we've got to be careful here because the question does say give a reason for your answer. So because the gradient is the highest here. You could say this is where the line is the steepest, or anything along those lines. Some students, they will work out the gradient of each of the three sections. There's no need for 2 marks. There's absolutely no need for that. Okay, it says work out its greatest speed. Well, it's obviously it's going to have its greatest speed where the line is the steepest. And so we just need to figure out, well, we already know that's 20, figure out where along here it is, probably get it a bit closer, that's about right. So we've got to figure out what the scale is. So I think that's halfway, so it's going to be 300 there. And each of those little squares is going to be 20, so that's going to be 320, 340, 360. So that's going to be 360 there, and just carry it on, 380, 400, so we know we've got the right scale. So it's going to be 360 distance and 20 seconds. And we're going to be doing this in meters per second because the units are in the question. So to work out speed, we know that it's distance over time. And we know the distance was 360 and the time was 20. So we can divide time bomb by 10, which would be 36 over 2, and then 36 divided by 2 is 18. So it's going to be 18 meters per second. Next up, we've got OCR's question, and this is a simple question, but a lot of students don't realise how simple this is. And we've got quite a complicated graph here. We've got it going up, then across, then up again. But the question asks us to work out the average speed. And the formula for average speed is dead simple. So average speed is total distance over total time. So we just need to work out the total distance, which is the distance at the end. So here, it's 160. Need to work out the total time, which might be a bit more difficult. Let's get our lines in. So, need to work out the scale. So what is that? So halfway is going to be 1050. And if we carry that on, for every 2 notches it's going to go up by 50. So this one here is going to be 1150. A little bit difficult, but we can cope. Okay. Which of course is completely wrong because it's in time. Oh, this is not seconds. So that would be 1030, and that would be 1130. Okay, so if we start at 9 and finish at 11:30, that will obviously be 2.5 hours. The total time is 2.5, and then we can do that on our calculator if it was a calculator paper, but this is not a calculator paper. So what we can do is we can times top and bottom of that fraction by 4. So I can make that bottom one a 10. So I can just quickly over here times it by 4. Probably do this in our head. That'd be 24. 4 plus 640. And then 640 divided by 10 will be 64. It's a little bit harsh for a non-calculator paper, but we can cope, especially question 2 on the exam, but definitely worth it for 3 marks. Our last question comes from AQA, and in this question it's really important that we realise that we're working with a velocity and not speed, or distance I should say, sorry. So it's not a distance time graph, it's a velocity time graph, and so the gradient now is not speed, okay, the y-axis is speed or velocity. The gradient is now acceleration. So it says, after how many seconds was the acceleration 0? Now what that's saying is at some point in this graph, the acceleration becomes 0. Now since acceleration is the gradient, then when the line is horizontal, the acceleration is 0. Now you might look at that graph and think, well, there's nowhere that that line is horizontal. Well, if it's gone from positive to negative, it must have been horizontal for a section of it. And it's where the graph's turning point is, where it moved from being positive to negative, and that's this bit here. So we've kind of got to read off what that bit is. And so let's look at the scale first of all. So it's taking 10 squares to move up 5. So it will take 2 squares to move up 1, so it would be 6, 7, 8, 9, like that. Okay, and so it's somewhere between 6 and 6.5. I'm probably just going to go for 6.25, split the difference. Probably on this exam, I haven't looked at the mark scheme, but it's probably going to allow anywhere between 6 and 6.5, I would imagine. And then it says work out the distance travelled in the last 15 seconds. So we've got to figure out where the last 15 seconds is. So it finishes here. Let's use a different colour. It finishes here. So 15 seconds back from that would start here. And so let's just draw that in so we know what we're talking about. So it's that bit and that bit. Now we need to ask ourselves, how do we work out distance on a velocity time graph? Well, distance is just represented by the area underneath the line. So it's this area here. Totally rubbish at colouring in. Good enough. So it's that area there. So distance is the area underneath the line. I'm just going to remove that because I don't want people thinking that you need to colour it in, because you definitely don't. Please don't colour it in. But we use something called, well, we just work out the area. Okay, I was going to say it's something called trapezium rule. We don't need the trapezium rule because it's not really a curve. It looks like a straight line, but essentially we don't know it's a straight line. It could be a little bit curved, but the shape looks like a trapezium, so we use a trapezium to work it out. So we've got to figure out where the trapezium is. Well, the right angles are here and the parallel sides are here. So this is kind of A and this is B. This would be the height, because the height is the line that's 90 degrees to both of the parallel sides in a trapezium. And so the formula for a trapezium, so the area is half A plus B H. So it's half times A, which is, and we've got to read this off now. I'm going to probably use a different colour. So it's whatever this is. So it's going up in ones, isn't it? So it'd be 22. And let's look up what B is. That's just, it's probably a little bit low, so I think that's 18. Go for 18 on that. And times the height. Now the height is given to us in the question, it'd be 15. Okay, so 22 plus 18, well 2 plus 18 is 20, so that'd be 40. So it's half of 40, which would be 20, times 15. Now when you times something by 20, you can times it by 2 and then times it by 10. So 2 times 15 is 30, 30 times 10 is 300. So the answer would be 300. Now, because this is paper 1, it's an uncalculator. So say for this one, if you got like 17.9 or you were trying to be like super precise, on an uncalculator paper, it probably will be a nice number. So just double check, like I did. That line there was probably a little bit too low. So probably if I lined it up correctly, it would be 18. And it would be absolutely perfect, which it is. So just watch out for that on the non-calculator paper. On the calculator paper, they can normally pick whatever numbers they want, but they're normally a little bit nice on the non-calculator paper. Well, I hope you enjoyed today's video. If you did, please click like. If you want to leave a comment on anything we've discussed or you want suggestions for future videos, please feel free. We release videos every single weekday, that's Monday to Friday, at 9 o'clock in the morning. So click subscribe to make sure you're up to date and click the bell to make sure you're notified when we release videos. If you haven't already, go to our website onmaths.com, which has loads and loads of free resources for you to try out. And you can even sign up for free. There'll be a card that magically appears above me as I speak. Otherwise, thank you very much, and I'll see you tomorrow.